Welcome to my Switching, Routing, and Wireless Essentials course. This should be the CCNA version 7 curriculum. This is the second of 3 courses. Module 11, Switch Security Configuration. We're going to be looking at port security, and we're going to be looking at ways to mitigate VLAN, DHCP, ARP, and SDP-based attacks a little more in depth than we did in the previous lectures. So let's go ahead and jump right on in, implementing port security. Well, first thing is, we should be securing all unused ports, meaning they should be turned off. If there's not a reason for them to be on, you can do an interface range and power all of them off. The fact that ports are left on presents one of the larger security risks. We can mitigate a lot of common types of MAC address table attacks by not allowing the device on the network. So by limiting the number of permitted MAC addresses on a port, we can actually help mitigate these types of attacks, and we can do this through port security. Port security is used to control authorized access to the network via MAC addresses. How do we enable port security? Well, we have to go to a statically assigned interface, meaning, let's say interface fast Ethernet 01. We have to hard code it to be an access port, at least in this course. In the higher level courses, you can do this on trunk ports, but again, outside the scope. So what we're going to end up doing is go to the interface, hard code it to a access mode. From there, we're going to do switch port TAC security. Port security actually enables that function, but it has to be in switch port mode, and it has to be set to an access port. There are options for port security. Here you'll notice we have, is it turned on? What is the status? And what is the violation mode? Those are two big things we need to talk about. We also have an aging section, and we have a MAC address section, meaning how many MAC addresses can it learn? So again, when we're looking at this output, notice port security is enabled. Notice the violation mode, and notice the MAC address maximum option. If an active port is configured with port security command, more than one device is connected to that port, the port will transition to an error disable state if that MAC address is not known. So some of the options we have. So we're going to have to talk about things like aging and MAC addressing and maximum violation. Each of these portions actually define how port security is going to function. And they're very important, so we have to cover each of those criteria. Alright, so limiting and learning MAC addresses. So what we're going to have to do is, if we want to define how many MAC addresses that port can learn, we would issue underneath that interface switch port mode. Sorry, not switch port mode. Used to be landing. Switch port space port TAC security space maximum space and a value. The default value is 1, and you can have between 1 and 8,192 possible MAC addresses learned. Normally, I've seen this set to 3 or 5. Normally less than 10 MAC addresses. And again, this is the maximum amount of addresses it can learn. So the next question is, how can they learn addresses? There are 3 main ways. The first way is manually configuring it, and you do that by issuing a switch port security, MAC address command, and at the very end, let me grab my pen, this is where you type the MAC address. So you basically say, this is the MAC address that you know about, there you go. You can also dynamically learn addresses by just turning on switch port security. So when switch port security command is entered, the current source MAC address of the device connected to the port is automatically secured and is not added to the running configuration. If the switch is rebooted, the I'll have to relearn that MAC address. The important part is it's not in the running config. That means when we do our lab for this and we configure it, you may encounter the MAC address not actually being configured. What you have to do is, the third way is use a sticky. Basically, when the administrator enables the switch to dynamically learn an address, you have to stick them to the running configuration by using the switch port mode security MAC address sticky command. And then saving the running configuration will commit the dynamically learned MAC address to memory. If you do not do sticky and then save the running config, then this will not function and you will notice an error when verifying it. I'm going to point this out in the lab so we can see how that functions. So again, this is how we'd be doing it on the right hand side, left hand side, my right hand side, setting it to access mode, turning on port security, setting the maximum number if you want, statically setting up a MAC address, and then applying sticky. That way, sticky says relearn that MAC address. Sticky would also take whatever MAC address is currently plugged in and will learn that as well. How can we verify? We can do this by doing a show port security or show port security interface and give it the interface. That way we can see the status, we can see if port security is enabled, the status, violation mode, and if the different timers. We can also see total MAC addresses that are configured and maximum MAC addresses. So again, we're going to go through this in our lab, but I wanted to show what this would look like. So one of the things that was discussed was aging. Port security aging can be used to set the aging time for both static and dynamically secured addresses to keep. There are two main types, absolute or inactive. The absolute basically means that that secured address on that port will be deleted after X amount of age time. Inactive basically says on the port and delete if it's inactive for X amount of time. That way, they're not always hard-coded, but you can set so that if, a computer is idle for, 100 minutes, then delete it. That way you can allow a new timer to come on. So using aging to remove secured MAC addresses on the switch port without manually deleting the existing secured MAC addresses, some benefits. However, managing a large network, this becomes a little more cumbersome, but it all depends on the appropriate policies. However, aging on statically configured static addresses can enable or disable per port, which we already knew that. The timing is the important part. If we know what we're trying to accomplish and we do the appropriate timing, then we can actually lessen the security risk. Not saying completely remove it or mitigate it, but we can lessen it. How do we set our aging timer? Well, we'd go to the interface, switch port, port security, aging, and we can either do a static or a time. With that, we could do time either based off of the absolute time or the inactivity time. And from there, we can actually see what we're trying to accomplish. So for example, here we have a aging of 10 minutes of inactivity. So we set the time and then we set the type. And you can see that here, aging, time, 10 minutes, type, inactive. And what will end up happening is you can now see the age time and age type being modified. It's now 10 minutes and inactivity. So what about these different types of violation modes? Violation modes come in three main flavors. Shutdown, that's the default, restrict, or protect. So basically what happens is if a MAC address that is not configured is plugged in, the port will transition to an error disabled state immediately and it turns off the port. you actually have to go back into the port and re-enable it. Issue a shutdown and then issue a no shutdown and turn that port back on. So the issue with that is if I'm working and I have two laptops, and I have one laptop that's appropriate and one laptop that's not appropriate. One that has a Mac that's learned, one that doesn't. I plug my laptop into that port, not realizing it's the wrong company. So that MAC address does create a violation, so that port's an error disabled status. Well, if I unplug it and I plug back in the laptop that is allowed, what happens? Well, with shutdown mode, that port's shut down. It's no longer listening. It's no longer accepting anything. So that's the negative with that. If we set the mode to restricted, basically restricted will drop the packets or frames for the unknown MAC address until that MAC address is learned or allowed on that network. That way, in the example I just gave with the two laptops, if I plug into a restricted port, then it will drop the packets from one laptop. When I plug in the correct laptop, the correct MAC address, it will continue to process that as if there are no issues. Lastly is protected. Protected is the least secure mode, and again, basically it does the same thing as restricted, except it doesn't log anything. With restricted, it logs. It logs the violation, it logs the violation counter, it also generates system log messages, and so forth. So error disabled state basically is the state that's a shutdown and it turns off the port. I brought that up because we have to go over the different states. Here we have an example. We can do a show port security interface if we wanted to. We've set the violation mode to restrict, and we can now see that it's restricted. If there is a violation, we can see that it's going to transfer to a secure shutdown instead of a error disable state. So we've already talked about error disable, and this is when the port is placed in an error disabled state and no traffic is allowed on it. The port protocol and link statuses are changed to down, and the LED is also turned to down, and this is the system log message that you should be receiving. So we can also see that you can get a violation counter. So if the port is in error disabled state, you can do show port security, navigate to that interface, you can see the counter. You should determine what caused the violation, and if it's a false positive, you can do a shutdown and re-shutdown command on that interface to turn it back on. With port security, we can also do just a show port security, and we can see the ports. We can see the MAC secure addresses, current addresses, violations, and action count based off of a per port section. We can do a show port security interface and navigate to that interface for a little bit more detail. We can do a show run to verify as well. Here you're going to notice that we're doing a combination of sticky with a sticky MAC address. So it's not just sticky, we're doing sticky and a MAC address that's also acceptable. Here again we're doing show port security, but we're adding the addresses. So it's no longer sorting the default show port security by port numbers, but we're now sorting it based off of addresses. We have a packet tracer verifying all of this. So we're going to go through some of those packet tracers that really questions, concerns, please reach out. Thank you.